So here on warm-up 1 for Unit 2, it might help if we make a couple of little notes first on some, like, clues about these history questions. So, let's write some clues down. First of all, if you see the word gold or the word nucleus, that's going to be a question about Rutherford. If you see the word orbit, or if it's talking about electrons in fixed energy, that's going to be talking about Bohr. Any other time you see the word electrons, or if you see the word cathode, that's going to be talking about Thomson. And if it's not any of those clues, it's probably a question about Dalton. So let's take a look at what we see here. Number 1, who bombarded gold foil with alpha particles? You see the word gold? Guess what? That's a question about Rutherford. Number 2, who devised the first atomic theory? Well, that's not a question about gold or the nucleus. It doesn't say orbit. It doesn't say anything about electrons in fixed energy or electrons in general or cathodes. It's none of those, so this is our leftover boy, Mr. Dalton. Who developed the planetary model of the atom? You have to know what that model looks like. That's the one where you have the nucleus in the middle and the electrons orbiting the nucleus, similar to how the planets orbit the sun. Oh, did we just use the word orbit? I think this means this is a question about Bohr, because we're talking about electrons orbiting. For number 4, the first subatomic particle, again, you gotta know what those are. Those are protons, neutrons, and electrons. And the first one to be discovered was the electron. So if this is really a question about electrons, this is a question about Thomson. Number 5, who discovered the nucleus? That's our keyword that goes with Rutherford. Number 6, who devised the plum pudding model, also called the chocolate chip cookie model? That's the model where you have your atom and just kind of floating around in the atom like plums in plum pudding, or like electrons in a, or like chocolate chips in a chocolate chip cookie. The electrons just sort of float around in there. This model does not have a nucleus, it only has electrons. So if this is a model with only electrons, this is a question about Thomson. Who was the first to suggest electrons had a fixed energy? That fixed energy is a buzzword for Bohr. Who said all atoms of an element are identical in size, mass, and other properties? None of this matches any of our other clues, which means this is a question about your leftover boy, Dalton. If we look up here at number 9, who determined the mass of an atom was concentrated in the center? That part of an atom where mass is in the center, that's the part of the atom called the nucleus. If this is a question about the nucleus, this is a question about Rutherford. Number 10, I see the word cathode. I don't even have to read the rest of the question. This is a question about Thomson. Number 11, who discovered the atom is made up of mostly empty space? Again, this is one where you have to know what that model looks like. When we first found out the atom was mostly empty space, someone had just discovered the nucleus and thought that electrons were just sort of floating around outside but spread out from each other. So the rest of the atom was the empty space, but there was a nucleus in the middle, and the dude with the nucleus was Rutherford. Who had the idea of a basic indivisible particle? This again does not match any of our other dudes, so this is our leftover boy, Dalton. Who concluded all elements contain electrons? That's our buzzword for Thomson. Who did an experiment with cathode ray tubes? That's another buzzword for Thomson. And number 15, who said atoms are neither created nor destroyed, just rearranged? That's our leftover boy, Dalton. When we get to this bottom section, It helps if you know what these numbers after the hyphen are. If it says element hyphen number, that number after the hyphen is always a mass number. So if they give you element hyphen number, you can take that number and copy it down as your mass number for all the ones that it gives it to you. If they write it in nuclei notation, where it's a top number, bottom number situation, the top number is your mass number. So you can take that number and just copy it straight down as your mass number. If they give you a top number, bottom number, that bottom number is the atomic number. So you can copy down the bottom number as your atomic number if they give you a bottom number. You'll notice that row 1 and row 2 are both magnesium. If they're both magnesium, then they're both the same element and the same atomic number. So if this was magnesium 12, which I knew from this bottom number, this also is magnesium with an atomic number of 12. This bottom number told me argon was element number 18. Well, this next row, row 4, is still argon, so it's still element number 18. And then this bottom one, fluorine, is the only one where they never give us a bottom number for that element. So we're going to have to look it up on our periodic table. And the periodic table says that fluorine's atomic number is 9. And I'll also point out that the periodic table tells you that that top number is the atomic number. So all you have to do is find fluorine and then use this little legend, this key, to tell you the top number is the atomic number. That 9 must be the atomic number. If you know the atomic number, then your number of protons should be pretty straightforward, because it should be the same as your atomic number. So you just copy those straight down. And your number of neutrons is the only one that's even mildly tricky. It helps if you know that mass number is your protons plus your neutrons. So that means if we're looking for neutrons, we have to do mass number minus protons. So 24 minus 12, 26 minus 12, 40 minus 18, 36 minus 18, 19 minus 9. There you go.